Now see, in this question they have said a solid of density. So let us write down all the information given to us. First of all, they have given us the density of solid. Okay, so density of solid is known to us as 2700. That's the density of solid. Then they have given you volume of the solid. So volume of the solid, it's given 0.0015 meter cube. That's the volume of solid given. Now the question says that body is completely immersed. Now remember, whenever body is completely immersed, then whatever will be the volume of the body, same will be the volume of liquid displaced. Is it clear? Whatever will be the volume of body, same will be the volume of the liquid displaced. So we can write, let us represent volume of liquid displaced by small l, small v. So we can say this is volume of liquid displaced. Now this volume of liquid displaced will be equal to volume of solid. Now remember this condition, that whenever the question says body is completely immersed, then you will take volume of the liquid displaced is equal to volume of the solid. Okay, now what else given? They have given us density of alcohol. So density of liquid is also known to us, and that is 800. And if you go through the question, at last they have given you value of acceleration due to gravity, that is 10. So this is the information that they have given us. Okay, now using this information, let us see what they have asked us to calculate. In the first part, they have asked us to calculate weight of solid. Okay, now remember, whenever we have to calculate weight of a body, so we are going to use the formula mass into gravity. Now in case mass of the body is not known to us, then what we will do, we will replace this mass by volume of the solid into density of the solid. Then we get this formula. Now volume of solid is known to us, it's 0.0015 into density of the solid, that is also known to us, into gravity, that is also known to us, 10. Now let us do the calculation for it. So if you remove the decimal, you are getting 15 upon 10,000 into 2700 into 10. Then you can reduce 5 3s are, 5 2s are, so you are getting 27 into 3, that will give you 81. 27 into 3 will give you 81 upon 2. So we get the weight as 40.5 Newton. So this is the weight of the solid. Now let's see what they have asked us to calculate in the second part. They have asked us to calculate upthrust. Okay, so let's calculate the upthrust. Now upthrust, that is the buoyant force. Formula for upthrust, we have volume of the liquid displaced into density of the liquid into gravity. So we are going to use this formula for calculating upthrust. So volume of the liquid displaced here is same as the volume of solid. And when do we apply this condition? When the question says that body is completely immersed. So volume will be same. Density of liquid here given is 800. Gravity is given as 10. So let's solve this one. So it's 15 upon 10,000 into 800 into 10. So let's reduce it by 5 3s are 5 2s are 2 4 are. So you are getting upthrust as 4 3 12. So upthrust is 12 Newton. Now weight of the body 40.5 Newton and upthrust 12 Newton. Now remember, weight of the body acts in the downward direction, whereas upthrust acts in upward direction. Now the third part says what we have to calculate over here in the third part: apparent weight of solid. Now let's calculate the apparent weight. See how you will calculate the apparent weight. To calculate the apparent weight, whatever you got the weight of solid in air, from that you will subtract upthrust on the solid. So weight we got 40.5 and upthrust is 12, so you will be getting it as 28.5. So this will be the apparent weight. Now in the fourth part, see what the question says in the fourth part. In the fourth part they are saying, will the apparent weight of solid be less or more if it is immersed completely in brine solution of density 1050. Now in the fourth part they are saying that they are changing the liquid. If you will change the liquid, remember upthrust will also change. So in the fourth part, as they have changed the liquid, so upthrust will also change. So we need to calculate now upthrust in brine solution. Formula will be same: volume of liquid displaced into density of liquid into gravity. Now as you can see, again they are saying that the body is completely immersed. Now if body is completely immersed, again the volume of liquid displaced will be same as the volume of solid. So volume of liquid displaced will be same. Now we have changed the liquid. Now the liquid is brine. So we are going to take density of brine solution, and you can see the density of the brine solution given to you is 1050. So we are changing the liquid. So density has changed. Gravity is 10. So it will be 15 upon 10,000 into 1050 into 10. So let's solve it. You reduce it by 5, you reduce it by 5, 20, you reduce it by 5, you reduce it by 5. So here you are getting 21 into 3, that is 63 upon 4. So when you divide it by 4, you will be getting 63 divided by 4. So upthrust 63 upon 4 gave us 15.75 Newton. Now this is upthrust in brine solution. So as upthrust has changed, so let's find apparent weight in brine solution. So whatever was its weight of solid in air, from that you will subtract this new upthrust. So weight in solid was 40.5 and the new upthrust is 15.75. So let's subtract this 40.5 and from that we have to subtract 15.75. So the result is 24.75 Newton. So the question has asked whether the apparent weight of solid will be more or less. See, in the first case, when it was immersed in alcohol, apparent weight was 28.5. Now when immersed in brine solution, its apparent weight is coming 24.75. So you can say that the apparent weight has reduced. So apparent weight in brine has reduced in comparison to apparent weight in alcohol. Hope it's clear to you now.